In this lecture, we talk about left censoring. Now, sometimes the data is censored below a certain threshold. So this is called left censoring. So in this case, you do not use the standard linear regression, but you use a censored regression model, and this model is called the Tobit model. Now, for example, consider a model where the response variable is score, and the lower possible score is 40. So there is a lower limit on the score, which is 40. So anyone who takes the test will be given a minimum score of 40. So even in SAT, you have a minimum score. Similarly, say you are testing radon in a house. The minimum level you can test with the equipment is 0.01 PCI. So below this level, the equipment will not test the radon in the house. So there is a lower censoring. Similarly, to check the chlorine level in the water, or to check certain mineral content in the water which is coming to your house, you can have a minimum value which can be tested by the equipment. So the equipment cannot test below a certain point. So you always have a left censoring of data. Now if you have left censoring of data, we will use a Tobit model, and for example, consider a response variable score, and this is limited below by a lower value of 40. So anyone who takes the test, he gets a score of 40, but the maximum score is 96. So say this test is out of 100, the maximum score a person got was 96. So we know this model is not censored above, but it is censored below by a value of 40. So we want to predict the score. So this is the response variable for some test, and the predictors for this score are writing score, reading score, math score, and race. So these are the predictors. So again, here race is a categorical variable. So this is a categorical variable. It takes on value 1, 2, or 3. So your model is like this. So the output of the model is score, and the score is bounded below by a threshold value of 40. So we have to use a Tobit model. So input into the score is your reading score, your writing score, your math score, and the categorical variable race. So race takes on values 1, 2, or 3. So first you clear the memory by using this rm command. You require this vgam package. So you read dataset into D3. This is the address, this is the name of the file. It's a text file, header is true. So first two rows of your data set, row 1, your reading score is 36, writing score is 22, math score is 26, and this student scored 40 on the exam. His race was 1. Another data point is reading score is 25, writing score is 11, math score is 22, the score he got was 52, his race was 1. So again, your score is the response, and the input into the model is write, read, math, and factor race. So you have write, read, math, and then you have factor race, because race is a categorical variable. Now again, we use the Tobit model here. The lower value is 40, and your data is D3. So this is your data which you are reading in, and then you have to take the summary of the model. So we will just worry about the coefficients. For the coefficients, we are not given the p values, so we have to do with z values. So we take the absolute of z value, that is, if it is negative, you drop the negative sign. If it is positive, you keep it as such, and you check if it is greater or equal to 2. If it is greater or equal to 2, then it is significant. If the z values are less than 2, then it is not significant. So you start with 5.86. This is greater than 2. This is positive, so you don't have to do anything. So this is significant. 40.6 is greater than 2. This is significant. So this is negative value. You first convert into positive value, which is 0.76, and you see this is less than 2. So this is not significant. So we will drop the writing score completely. Now your reading score is 4.5. This is greater than 2. This is significant. This is 8.18, greater than 2. 2.9, greater than 2. This is significant. 3.6, this is greater than 2. So this is significant. Now we need to interpret these values here. So to interpret it, we have to keep in mind two situations. Number one, if your score is greater than 40. If your score is greater than 40, then you go ahead and interpret them exactly as in linear regression. But if your score is equal to 40, so you could always say it is less than equal to 40, but your data is censored from below. So if score is equal to 40, then this interpretation will not do. You cannot interpret it as a linear regression. In that case, again, you have to compute the probability of it being equal to 40, which is really easy to compute. You basically count the number of values which have score of 40, and you divide it by the total number of observations, and that will give you the probability of score being 40. And you take that probability and then you weight each of these coefficients by this probability, and that will tell you what is the difference between various students who score exactly 40. So whether one student is better or worse than other in case they have both scored 40. Now we are not going to use this difficult interpretation too. I think it is always a good idea to come up with a new model to check students who have scored exactly 40 rather than using this model. But you can always use the Tobit model if you want to reduce your work. So we are just going to focus on this one where score is greater than 40, and we can use linear regression coefficients. So first intercept is standard intercept as it is in linear regression. Intercept 2, you exponentiate it, that will give you the standard deviation. Now your reading score 0.48 means that 1 unit increase in reading score will increase the score by 0.48. So 1 unit increase in the math score will increase your total score by 0.99. And if your race changes from 1 to 2, your score will increase by 4.5. If your race changes from 1 to 3, your score will increase by 5.9. So standard what you do in linear regression. So 1 unit increase in reading score will increase the total score by 0.48. Similarly for math, and so on. Now since writing is not important, we need to drop it. So we make another model M2. Now score is a function of read, math and race. So writing is no longer there because we want to use prediction now. You use the Tobit model. Lower threshold is 40. Data set is the same, D3. So you have the data frame. Your reading score is 40, 40, 40. Math score is again 40, 40, 40. Race is 1, 2, 3. So you feed in this data frame into your new model M2, and your type is response. So you feed in 40, 41, you get a score of 80.26. You feed in 40, 42, you get a score for 84.71. You feed in 40, 43, you get a score for 86.400. So this is the input into the model, and your output is the score. So for row 1 you get 80.26. Feed in this. For row 2 you get 84.716. You feed this in. For row 3 you get 86.400.